Hello everyone, and welcome back to the mill turn training videos. In this video, we're going to be focusing on the last of the facing operations, or the operations that are on the face of the part, which is going to be this pocket. And if we look kind of closely at this face, and if I look down normal to this face, what we're going to see is that we have a pocket, but then we also have some tapered walls on the periphery of the pocket. So we're going to actually do this in two different operations, one that addresses the bulk material coming out, and the other one in the next video to deal with the 5-axis motion on the outside of that pocket. So to deal with the pocket initially, I'm going to make sure that I'm going to have the last operation on my list selected, and I'm going to come into pocket. And when you're in pocket operation, this is a 2D toolpath. So you have the different modes of selections that you may have seen in other videos before. We can do simple chains. I like to use feature recognition with chains. Now we need to make sure that our coordinate system is aligned to the face of the part. On our last video, we did the angled walls and the drilling at those angles. So my coordinate system needs to be set back to Mach 1 position 1. So now we're perpendicular to this front face. So when I come in and collect in the geometry, I'm going to come down and I'm going to make sure that I grab the bottom edge of the pocket. So it's going to chain the bottom edge, and I'll collect this into my toolpath. Now, with this feature recognition mode, once I select a tool, you're going to see something happen that you're not going to see if you were to use simple chains. But because we are using feature recognition, when I come in and select a tool, I want to grab a 5mm tool from my carousel. So I'm going to make sure it should be tool number 69. So I'm going to come down and grab tool 69, which is the 5mm tool, and I'm going to use this one for my operation. That feature recognition mode gives me a very nice preview of the area where that pocket is going to be cut. And I was very careful to make sure that I grabbed that bottommost pocket, leaving material on the walls for my 5-axis toolpath, which we're going to cover in the next video. Your levels are going to be pretty well set because of this feature recognition mode. So it's seeing the depth of the part, it's seeing how much material is there, and it's going to be set. We're going to take it in one pass. 1.5mm should be fine. And then I can change anything with step overs if I wanted to leave additional material on the walls. But in this case here, I think we're pretty fine. We're going to do a helical entry into the part. I'll come in and hit save and calculate on this. It's going to give me a little warning about internal corner radiuses, and that's fine. And it will go out and give me a toolpath that deals with that pocket. If I were to take this into solid verification, Solid Verify will load it up. I can come in and hit play. And when it's done and I do a compare on this feature, we should see that we still have excess material on the walls, which we're going to take in our next video with the 5-axis toolpath. But I'm going to close out of this for a second. And let's go in and let's take all of these operations into machine simulation. So I'm going to take this into machine simulation now so I can see the kinematic motion of the machine. Now, depending on what your system is set to by default, okay, it might be using a Cartesian coordinate system for positioning, so X and Y movements to cut that pocket, or it might be using polar interpolation, X over C interpolation. Let's just view what we've got. So if we were to come out and hit play, what I want you to pay attention to is the motion of the machine. So our helical entry into the part, and then as it's cutting around and going around this pocket, it is using the y-axis to get around the part. My c-axis is stationary and it's not rotating or moving. And that might be acceptable. If your machine has enough y-axis travel to do that, then that's fine. If your machine doesn't, then at that point we need to change up that motion. So just to kind of show you how that is done, what I can do is come back to that pocket operation, double click on it, and we're going to kind of continue down the list of parameters. So I'm going to go into motion control. If I want it to be polar interpolation instead of Cartesian coordinate system at this type, I'm just going to select the 4th axis mode, recalculate it. You're not going to really see anything change on the screen here. It's the exact same tool path technically, but what happens in machine simulation now, when I load this back into machine simulation, and then I'm just going to cursor down once it's fully loaded down to that operation. It will update my machine to that current position. Now I'm going to see that I'm running this with polar interpolation. So depending on your preference and how your machine is equipped, you have options here. Let us know if you have any questions or if you need help in any way. We're happy to help. Thank you for watching this video. And in the next video, we're going to deal with the 5-axis swarf cut on the walls to deal with the angle wall of that pocket. Have a great day.